Hello, my mathematical geniuses. Today's a really fun lesson. We're going to look at going from standard form back into vertex form. Okay. Now, at first, this is going to feel, for those of you maybe who don't like algebraic steps as much, this might feel a little overwhelming. We're going to do lots of examples together though, and then you're going to do lots and lots of practice and you're going to feel super, super comfortable about it. Okay. So to remind you, yesterday, in our last lesson, we built an equation in vertex form, and then we practiced moving from vertex form to standard form. Okay. And to do that, we had to take that binomial, we had to square it, then we had to distribute the a value into all those terms. And then there was always those kind of two numbers at the end that we could combine together, and that got us into standard form. So today we're going to go in the opposite direction. We're going to start in standard form, and we're going to try and figure out how to get it to look like vertex form again. Because remember, vertex form tells us more stuff, right? Vertex form tells us the vertex. And then when it tells us the vertex, that also means we know the axis of symmetry. We know the max or minimum point. We know the range because of the max and minimum point and the a value. We know whether that graph opens up or down. Okay, so we get all this information from vertex form. We don't get as much, we get some, but we don't get as much information from standard form. Okay, now to start us off with, what we're going to do here, I'll just read this right quick. We know that equations in vertex form gives us much more information than that of standard form. Therefore, when we have an equation in standard form, we want to switch to vertex form. Okay, so just a reminder, standard form is that ax squared plus bx plus c. And now vertex form is that y equals a bracket x minus p all squared plus q. Okay, all right, now I want you to notice here that you've got this little picture, two people talking up here. Whenever you see that on my PowerPoint slides, that means this is not in the workbook that you're working through. This is just me having a conversation with you. So don't try and find it in your workbook. It's not there, okay? The vertex form always has a binomial squared, right? It's always x minus p all squared. Now, this comes from factoring a perfect square trinomial. So one of the things we want to talk about is how do we actually create, how do we force it so that we end up with a perfect square trinomial? Because if we had a perfect square trinomial, it'll factor into a binomial squared, and that will make this process much easier. So how do I make one? So I've given you some examples here. The first one is x squared plus 4x plus something. Now we know that we need that to equal x plus something squared, okay? And we know that whatever I stick here, I'm going to square it, and it's going to become that number there, right? Because yesterday when we were multiplying those binomials out, I kept saying square the first, double the product, square the last. Square the first, double the product, square the last. You remember me repeating that over and over and over again, right? So we know that whatever term goes right here, I will square it to get this term here, okay? The other thing we know is that I'd have to double the product of x and this number in order to get this 4. So really, I'm looking for a number that when I double it, I get 4, right? So that means I want a 2 here. Do you follow my train of thought there? And if I want a 2 here, this would then get squared to be this number, so this is missing a 4. So I know now that x squared plus 4x plus 4 would be a perfect square trinomial. I know that it would factor into x plus 2 all squared. Okay. Okay, let's try another one. Sorry, I just got to get my mouse back on here. There we go. So let's try this guy here. I know that whatever number I stick here, I need to double the product and get -8. Well, the only way to do that is to have this be -4. Right? So what you're noticing is this number here has to be half of this number here. Okay, then to get this missing piece, I take my new number, that -4, and what do I do with it? Well, square the first, double the product, square the last. That last number gets squared to give me the third number of the trinomial. So that's going to be a 16. Okay, that was quite a 6 there, sorry. All right, so I'm going to clear that and we'll do one more together here. I think you're catching on well. What do I need to put here so that when I double this product, I'll get the 10? Well, I have to put a 5. And if I put a 5 here, what does my number here have to be? It's going to have to be 5 squared, which is 25. Okay, so what we're finding here is the following. How do I make the right number, or how do I find, sorry, the right number to make this a perfect square trinomial? Well, I know that it has to be half of this guy. That's what's going to give me that back number. So I'm thinking about -6, but then I know I have to take that -6, and the last term comes from -6 squared. So I'm always taking that middle number, I'm going to half it, and I'm going to square it. Half of -12 is -6. -6 squared is 36. Okay, so I take the coefficient on the x, I half it, and I square it. I absolutely promise you that was the most confusing part of this lesson. Okay, if you understand that, the rest is just getting used to the steps and getting comfortable with the steps that we're going to take. Okay, but to find that friendly number, that's the majority of the battle right there. So if you're feeling okay so far, you're going to rock this lesson. Okay, no worries about that. All right, so here we go. We're going to rewrite the following functions in vertex form by completing the square. Here's what we got to do. Okay, and I'm going to, for this first example, I'm going to go real slow and I'm going to kind of write the steps out as we go. And then as we keep going through some more examples, I'll probably speed up the conversation because I don't want to bore you all. And you can pause me or rewind me if I'm going too fast, okay? But this one will take nice and slow. Remember, I always start you off with kind of an easier one too. So some of the steps are already done for you, but I want to show you all the steps that you would want to think about, okay? So the first one is factor the leading coefficient out of the first two terms. So the leading coefficient would be the number that goes right here. Now, there is no number that goes right there, which means it's a 1 right now, but I don't need to factor out the 1, right? So here's an example. This first guy, this first step is already done for us, okay? But think about the process of factoring for a second, because I'm trying to get you to feel comfortable with a visual here. When we factor a number out, what's left over gets in brackets, right? So although I'm not going to actually factor out a 1, I am going to put those first two terms in brackets like I did factor something out, okay? Again, I'm just kind of leading you into what it will look like for harder questions at the same time, okay? So I factored out my front number. If there was a number to do that with, it would be out here now. And so I put those first two terms in brackets because I factored out. Just again, take notice, it's from the first two terms, okay? This 7 here, he's just along for the ride right now, okay? I'm not actually doing anything with him yet. He'll come into play in a little bit. Okay, so it's this guy here that I actually want to create my perfect square trinomial from. Well, I absolutely know how to do that now, just based on the conversation we just had. If I want that to be a perfect square trinomial, I need one more number there, right? Because it's only a binomial right now. And I know I can find that number by taking the -4, halving it, and squaring it. -4 halved is -2. -2 squared is 4. So here's what I need you to understand. If this said x squared minus 4x plus 4, I would have a perfect square trinomial. That's exactly what I want. Okay, if it said that in the brackets, again, I'm ignoring the 7 for now, so don't worry about him. Okay. That would be exactly what I want because I know that that would factor into a binomial squared, okay? Okay, but I can't just do that. I can't just randomly throw a +4 into an equation. That would algebraically offset what the equation originally said, right? You don't get to just add a number. So I have to balance out what I just did. If I add the number in, I'm gonna also subtract it. So I'm going to add in a +4 and a -4. Why would I do that? Well, a +4 and a -4 is nothing. So I didn't change the equation, but I did get the friendly number that I wanted. I did get the +4 in there, okay? So the +4 has to come in along with a -4 to balance the equation, okay? I'm not allowed to change anything. Okay, so create your perfect square trinomial. Make sure you add and subtract the number in. So that's what I've done here, okay? Here's the perfect square trinomial that I want. This is what's going to make my life nice and easy, but I had to throw that -4 in so that I balance things out. Okay, So now I can't factor this right now because there's -4 in there. So I got to get rid of that -4. Well, how do I get rid of the -4? I do whatever I'm supposed to do for the reason of why it's in the brackets. Why is that -4 in the brackets? Well, it's being multiplied by the coefficient. Now, again, this one was the easier one, right? There is no coefficient there. So in order to get it out of the brackets, I can just move it out. It's like I'm going -4 times 1. Okay, so I can go -4 times 1 and move that -4 out of the brackets. And that will leave me with exactly what I want in the set of brackets. I've got that perfect square trinomial in the set of brackets. Okay, so get rid of your unwanted number in the bracket. Now there are two things left to do. Now the 7 comes into play because I can combine it with the -4. Those are just numbers out there. So -4 plus 7 is 3. So I'll have a +3 there. And then I've got this perfect square trinomial that will factor into a binomial squared. Well, what will it do? Well, I know it's going to look like this, binomial squared. I know that the first term has to be the square root of my first guy. I know the last term has to be the square root of my last guy. And I know the sign in the middle has to be the sign in the middle. So that's going to end up being x minus 2 all squared. X squared minus 4x plus 4 factors into x minus 2 all squared. Okay, if I was to take x minus 2 all squared, square the first, double the product, square the last, I would get x squared minus 4x plus 4. Okay, so factor and combine, there I am. And that is vertex form. Okay, I can tell you my vertex now is 2, 3. I can tell you my domain is member of the rails. I can tell you my range has to be greater than 3. I can tell you my axis of symmetry is at x equals 2. Okay, then I could plug in 0 for x if I wanted to and solve for y. If I'm looking for the y-intercept, I could plug, okay, can I talk about that for a sec? I already know the y-intercept. How do I already know the y-intercept? It's right there, right? Remember, the constant term is the y-intercept in standard form, okay? All right, cool. That was your first kick at the can. If that felt a little overwhelming, that's okay. It was only trial number 1. We're going to do it a couple of times together. And the joy of a video, you can pause me, you can shut me up anytime you want. You can rewind me and listen to me drone on over and over again, okay? Use this to help you really get into understanding the steps. I'm not going to show you the steps every time now. Now we're just going to start doing it together, okay? So if you want to see this example again with the steps, go ahead and do that. Okay, so now we're going to try x squared plus 2x minus 3. The first step is to factor out the coefficient from the first 2 terms. Again, there isn't one, so that one's kind of done for me. I just put those first 2 terms in brackets like I've already factored something out. Now I want to create my perfect square trinomial. Okay, in order to find that magical friendly number that goes right here, I need to take my middle term. It's not the middle term right now, but it will be the middle term, right? I want to take that middle term, half it and square it. So half of 2 is 1 and 1 squared is 1. So I know that if this said x squared plus 2x plus 1, I would have that perfect square trinomial that I'm looking for. Okay, I can't just add 1 though, so I have to add 1 and subtract 1 at the same time. That creates a 0. Okay, and the 0 allows me to do this without actually changing the question itself. Now I got to get rid of the -1. So in order to get rid of that -1, I do whatever it's being multiplied by out here, which right now is a 1, so it doesn't change anything. So I'll have a -1 on the outside now. I've got x squared plus 2x plus 1 on the inside, which is my perfect square trinomial that I can factor. So now these guys can be combined to be -4, and this will factor into x plus 1 all squared. Okay, so you end up again, the first number or the first term is the square root of that original first term. The last term is the square root of the original last term, and the sign in the middle is the sign in the middle. Okay, there is absolutely no difference between this equation and this equation. They represent the exact same quadratic parabola. It's not a line, but they represent the exact same equation. They're just in 2 different forms. Okay, the top one was standard form, the bottom one is vertex form. Okay. All right, we'll go again. Now, x squared plus 1/2 x plus 2. First step, So I threw a fraction in here for fun. That'll be neat. Hey, aren't you excited about that? Don't go get your calculators. You can do this without a calculator. Okay, first step is to factor the coefficient from the front, or the leading coefficient from the first two terms, sorry. Again, that's a 1, so it doesn't really do much right now. Okay, now I have to find that nice friendly number. Oh, I didn't mean to put that up there yet. I didn't mean to scare you, but just listen to me let me hide it for 1 sec. Okay, so I need to half 1/2. Half of a half is a quarter. Okay, then I need to square it. Well, when I square it, I just square the top, square the bottom. So that's where that 1/16 is coming from. 1 squared is 1, 4 squared is 16. Okay, so I added 1/16 and I subtracted 1/16. Now I have to get rid of the negative 1/16. I would multiply it by what's out here, but that's just a 1, so that's okay. So it's just going to come out here. And so right now I'm looking at this. And now I need to clean this up. Now, some of you may be like, what the heck just happened? Don't worry. I said I didn't want to do this with a calculator. So I took my 2, I just changed it to 32 over 16, right? 32 divided by 16 is 2. I did that so I had a common denominator. Now I can just say, hey, that's easy to do. Negative 1 plus 32, that's just going to give me 31 over 16. Okay. Don't you dare put any of this in decimal form. Okay. That's a big deal. We write with fractions only. We don't write with decimals unless we're specifically told to, or unless we're dealing with money. Okay. You must leave these as fractions. Okay. So that's going to give me 31 over 16 on the end. And if that freaked you out, this whole conversation, you can use a calculator. I'm not taking it away from you. I'm just suggesting maybe you don't need to use a calculator. Maybe your math skills are better than you think they are. Okay, and then here, I got to factor this down into a binomial squared. Well, again, that's going to be the first term is x. The last term has to be the square root of 1 over 16, which is 1 over 4. And then the sign in the middle will be the sign in the middle, which is a plus. So we end up with, sorry, my mouse wasn't on. We end up with x plus 1/4 all squared plus 31 over 16. Okay, do not write these as decimals. Okay, good. Let me just clear that ink. All right, so now the next little shift I gave you here is I threw a negative here. So remember, the very first step is to factor the leading coefficient out of the first two terms. So that's going to actually bring a negative 1 to the front, and that's going to leave me with x squared minus 6x. Okay, x squared minus 6x because I factored the negative out of the front two terms. Remember, I'm not doing anything to the 4 right now. He's just along for the ride. So this is the guy that I now want to make a perfect square trinomial. I need to take that negative 6, half it and square it. Half of negative 6 is negative 3. Negative 3 squared is 9. So I'm going to add 9 and subtract 9. Okay. When I do that, I'm looking at this now. Now, here's where you got to be careful because I've been kind of talking about this, but this is the first time it changes things. In order to get this negative 9 out of the brackets, because he's kind of in the way of my perfect square trinomial right now, I need to multiply him by whatever was outside the brackets. The reason these brackets are there is because that negative sign was going to get distributed to everything inside here. So when I bring that negative 9 out, it's actually going to become a negative 9 times a negative 1, which will be a positive 9. Okay. So I have a positive 9 and a positive 4 on the outside, and I've got x squared minus 6x plus 9 on the inside. Okay, so now I'm going to factor this. This factors into x minus 3 all squared, and I'm going to add these two together, which is 13. Okay. Everybody feeling okay out there? Hope so. It's actually quite fun once you get into it, once you understand the steps, okay? And once you do understand the steps, it can get very monotonous, like, and I mean that as a good thing. Like once you get going on it, there's not going to be like huge surprises. You just follow these steps every time. Okay. All right. 2x squared minus 16x plus 24. So I got to factor the 2 out of the first two terms. That's going to leave me with x squared minus 8x in brackets. I need to create my perfect square trinomial. So I have to half negative 8 and square it. Half of negative 8 is negative 4. Negative 4 squared is 16. So I'm going to add 16 and I'm going to subtract 16, right? I'm always adding and subtracting so I don't change the balance of the equation. Now I need to get that 16, negative 16 out of the way. So in order to get it out of the way, I got to multiply it by the 2 because that's why it's inside the brackets right now. 2 times negative 16 will give me negative 32. So on the outside here, I'm going to have a negative 32 plus 24. This is ready. This is my cute little perfect square trinomial. I can factor that into x minus 4 all squared, right? First term is the square root of the first term. Last term is the square root of the last term. Sign in the middle is the sign in the middle. And then negative 32 plus 24 is negative 8. So the vertex form equation of that guy would be y equals 2, x minus 4 all squared minus 8. Okay. So often on a test, the question isn't going to say, rewrite the following functions in vertex form. It's going to give you something like this equation and say, algebraically find the vertex. Well, if you have to algebraically determine the vertex, you'll have to put it into vertex form first. Okay. All right, negative 3x plus 6x minus 1. Sorry, negative 3x squared plus 6x minus 1. So I got to factor that negative 3x out of the first two terms. A reminder, you're factoring out a negative, so that will also switch the signs. That's going to give me negative 3x on the outside. In brackets, I'll have x squared minus 2x. And then I've got that negative 1 that's along for the ride right now. I want to make a perfect square trinomial inside here so I can factor it nicely. In order to find the number that I want, that will force it to factor nicely, I take that negative 2, I half it and I square it. Half of negative 2 is negative 1. Negative 1 squared is 1. So I'm going to add 1 and subtract 1. I got to get the negative 1 out. So in order to get the negative 1 out, I multiply it by the negative 3. That's going to be positive 3 on the outside. So I'll have 3 minus 1 on the outside. And I've got x squared minus 2x plus 1 on the inside. Okay, 3 minus 1 is 2. That one's easy. X squared minus 2x plus 1 factors into x minus 1 all squared. Okay. All right, good. Let's try just a contextual problem now. The flight path of a Justin Bieber CD that is thrown upwards from the roof of Centennial towards Petro can be modeled by the following equation. H of t equals negative 2t squared plus 6t plus 10, where t is the time in seconds and h of t is the height above the ground in meters. Algebraically determine the maximum height of the CD to the nearest tenth. So what I need you to see here is algebraically determine. Okay, that means I can't use my graphing calculator for this. I actually have to show mathematical reasoning on paper. And I want the maximum. Okay, well, the maximum height is part of the vertex. It's the Q value of my vertex. So I need to go ahead and complete the square. Okay, so yes, big, long problem. But in order to solve it, I'm going to do exactly the same thing I've been doing for the last few minutes and the last few examples. Okay, so I'm going to complete the square. I need to take the negative 2 out of the front two terms. That's going to leave me with negative 2 bracket t squared minus 3t bracket plus 10. Okay, then I need to make my perfect square trinomial. Well, I need to half this and I don't want to deal with decimals. Remember my lecture a couple of seconds ago. Don't use decimals. Half of 3 is 3 over 2. 3 over 2 squared would be 9 over 4, right? So if I take something in half, I just put it over 2. That's where the 3 over 2 comes from. And then when I go to square it, I just square the top, square the bottom. So square 3 is 9, square 2 is 4. Okay, so I'm going to add 9 over 4 and subtract 9 over 4. Now, the negative 9 over 4 has to get out of there in order to have my nice perfect square trinomial. That has to get multiplied by the negative 2 for me to do that. Okay, so that gives me positive 18 over 4 or positive 9 over 2. So I'm going to have a 9 over 2 on the outside, and I'm going to add 10 to that. So I might as well just call 10 20 over 2, so I have a common denominator. Okay. And then I've got this perfect square trinomial that I'll be able to factor. So this guy will factor into the front term will be the square root of the front term, which is t. The back term will be the square root of the back term, which is 3 over 2, and the sign in the middle will be the sign in the middle. So this is going to be t minus 3 over 2. And this will be 29 over 2 when I add that together. Okay, Now it said determine the maximum height. Well, the maximum height is my Q value, which is right here. Okay, 29/2 meters. So the height of the CD reaches a maximum of 29/2 meters before it starts falling to the ground again. Okay, so when you're asked a contextual problem, you also need to make sure you answer it. Now I did answer in decimals here. The question would probably say round to the nearest tenth of a decimal here, but because we're talking about a length, because we're talking about a real life object, that's why I did put it as a decimal for this one. So the maximum height of the CD reaches 14.5 meters. Okay. All right. You guys totally have this. Here is your task. Here's your homework for this lesson. And then in the next lesson, what we're going to do is we're going to kind of take this last example and kind of dive into that a little further. We're going to do a bunch of applications around quadratics and working with quadratics. Okay, so until then, have fun. Make sure you're doing your homework. Make sure your work is nice and neat, and make sure you're connecting with me if you have any questions. Okay, take care, guys. Bye-bye.